Good morning. Happy Thursday, and we are halfway through April. Yeah. So, hopefully you did the lab simulation, and this is kind of going to take that and leap off of it and kind of expound on it. Okay, so looking at reflection and refraction, the two properties of how light works. Like I said, hopefully you saw this in that lab simulation that you did. All right, here's a warm-up. Go ahead and try these. You have a large white board and you want it to appear red, either using paint or using light. What would you do? Well, if you're going to use paint, if you're going to use color, you shine a red light on it. But if you want paint, then you need to mix yellow and magenta together to get red. ESPN radio broadcasts at 101.1 megahertz. Mega meaning meaning a million. So you have to convert that. Then you have the speed of light, and you plug those in and solve for wavelength, and you get 2.96 meters. So just about 3 meters long is the wavelength. It's kind of, I don't know, it seems kind of big, but it's moving at the speed of light, so it's moving pretty fast. Okay, first thing we're going to talk about is reflection. All right. You've used reflection before anytime you've looked in a mirror. It's when an incoming beam changes direction from its original course and bounces back within the same medium. Like I said, that is basically the properties of a mirror. The light beam coming in is called the incident beam, and the reflected beam is the one that bounces off. And here's your plane or your mirror. One thing to notice is that those two angles are always going to be the same as long as they're bouncing within the same medium, meaning the same thing. So normal things would be air. So it comes in air and bounces off, and it'd be bouncing off in air. So those two angles are always going to be the same. And that's also the way we measure those angles, is always from that normal. Okay, for a concave mirror, thinking cave because you go inside of a cave, so it's kind of cave-like. All of them are going to bounce back and bounce toward a central focus point. So all those light rays are going to come in and bounce back. And that kind of makes sense because it's a cave, everything's pointing back toward the middle. The opposite of that would be a convex mirror. This left side is where the light is coming from. And so as they come in, they bounce off and they spread out. So they come in, they bounce out wide. These are actually used kind of opposites of each other. Your convex mirrors, those would be like the mirrors like in corners or on curves on roads when you want to see around something, because they take a lot of things and they shrink them down. They are also the type of mirrors that are your passenger mirrors. Those are also convex mirrors. Then we have refraction, which is part of what you did in your lab. So refraction is light waves being deflected, passing obliquely through the interface between one medium and another. It's a lot of big words. Basically what it's saying is when light comes in from one type of medium and goes into a different type of medium, then you have refraction. So, as a picture of this, you got this light beam coming in here from the top left, and these two colors are two different mediums, maybe air and water, or air and glass or something. As it comes in, once it hits that new material, it is going to refract. It's going to change its angle. And that angle change is going to be dependent on the type of medium that it's going to and from. As it hits, if it hits a more dense material, it's going to slow down. Yes, even the speed of light can slow down. If it hits a less dense material, it'll actually speed up. Now here on Earth, we don't have much less dense than air, but you know, a vacuum would actually be less dense. So then we have, just like we had two types of mirrors, we also have two types of lenses. All right. So the first one is a concave lens. So a concave lens, like I said, it kind of is hollowed out, so it kind of looks like a cave. And concave lenses spread the light out. So as light comes in, it spreads out. Kind of the opposite of what the mirror does. The mirror kind of focused it backwards. Well, the concave lens is going to spread everything out. A convex mirror, on the other hand, is looks like this, and it's the opposite of a concave, and it's going to focus your light beams. So your light beams come in and they focus at a central point beyond the lens. All right, that was it. That was a real short lesson. If this had been in class, we would have done some more stuff. We would have gotten some lasers out and played with those things, but yeah, just wanted you to see all that. So there's your homework. It's kind of spread out, and yeah, email me if you have questions.